All right, let's go over the single replacement questions. So there were 5 of them. So first one, we are going to say all these reactions take place. Remember, I know when we talked about the notes, there were things that you had to check, but we're going to assume all of these take place. All right. So we've got Na plus copper sulfate, which is the stuff I put in my pond to make it pretty blue, or at least kills off the algae. It also gives it some blue color too. All right, so I got to take this one. It's all by himself. Decide what charge should he be. If he had a charge, he would be a +1. So that means he's going to kick off the positive piece of these two. Well, remember, the positive piece is always the first one. That's this guy, and he's a +2. The SO4 comes from the polyatomic ion chart, and he's a -2. So sodium and copper, they're going to trade. So we're going to get copper all by itself, plus the sodium joins up with SO4. I do bring across that 4 because it came from the polyatomic ion page. All right, Cu, is he a diatomic dude? No, he's not, so he just stays by himself. Na is +1, SO4 is -2. Well, those don't cancel each other, so we got to put a 2 down here by Na. All right, now we balance this. So I've got an Na plus, I've got Cu, S, and 4 O's. That's got to equal to Cu plus 2 Nas, and S, and 4 O's. So I got 1 Na, I got 2 Nas, so I need some more Nas over here. I got 2 Nas, I got a Cu and a Cu, that's even. I got an S and an S, that's even. 4 O's, that's even. So the only thing I needed was 2 of this guy, and that's it. And that's all done. So that's the answer for that one. All right, next one. Next one, we got Li plus H2O. All right, so we look at that guy that's all by himself and go, what charge would he have? Well, he would be a +1. So we're looking for the positive in here. Well, H would be a +1, O would be a -2. So the Li is going to kick off the H. So we're going to end up with H all by itself plus Li and O together. All right, then we got to look at, well, this guy's all by himself. Is he diatomic? Yes, he is. He is diatomic, so we got to put a 2 there. Li, he'd be +1. O is -2, so crisscross those, and we get Li2O. All right, now we have to do our balancing. So I have an Li plus, got 2 H's and O, that's equal to 2 H's plus an Li, and an O. So we got 1 lithium, 2 lithiums. I need another one of these guys. All I got left is H's and O's. 1, 2 H's, 1, 2 H's, 1 O, 1 O. That's the end. So I need a 2 in front of this, and that's it. All the rest of them are singles. So there's the answer for that one. All right, next one. Next one's F2 plus KBr. All right, F, if he was he's all by himself, what charge would he have? He would be a -1 if he had a charge. So he's going to kick off the negative piece of these two. So this guy is +1, Br is -1. So he's going to kick off the Br. So Br is going to be all by himself, plus we're going to get K and F put together. Remember, don't bring any numbers across. All right, so we go to this one. Is he diatomic? Yes, he is, so we got to put a 2. And then we got K is +1, F is -1, so that's our formula for that. Now we just got to balance it. So in here I got 2 F's plus I got a K and a Br. That's equal to a Br and a Br plus I got a K and an F. So we'll start with the F's. There's 1, 2. I got 1 over here, so I need another one. So that gives me 2 F's. K's, I got 1 K, I got 2 K's. I need another K. And then I got 2 Brs, 2 Brs. There's my answer. So 1, leave it blank. 1, 2, put a 2. 1, leave it blank. 1, 2, put a 2. There's my answer. All right, we got 2 more. All right, Zn plus H2SO4. All right, Zn, he's in the middle of the periodic table, so he would have a +2. And there goes my lights. So turn those back on in a second. All right, Zn has a +2, so he's going to kick off the positive piece in this. Well, hydrogen's +1. SO4, that's from that polyatomic ion sheet, and that is -2. So the Zn's going to kick off the H all by itself. Don't bring that 2 across. We don't bring numbers across unless they're from the polyatomic ion sheet. Plus, and then we get Zn joins up with SO4. There's a number that comes across because it's on the polyatomic ion paper. H, is he diatomic? Yes. So put a 2. Zn is +2, SO4 is -2. Those cancel each other. That's my formula. Now I got to balance it. So we've got 1 Zn plus, I got 2 H's, an S, and 4 O's. That's equal to 2 H's plus I got Zn, S, and 4 O's. So I got a Zn and a Zn. So those are even. I got an S and an S. That's even. I got 2 H's, 2 H's. And I got 4 O's, 4 O's. This one's even just the way it sits. So I don't have to do anything more. All right, we got one more. Last one, Sn. Now we got a Roman numeral 4 plus NaNO3. Remember that Roman numeral 4, that just tells me his charge if when he joins up with something else. So we got to identify, because he's got that, he would have a +4. So that means he's going to kick off the positive piece. Na is +1, NO3 from the polyatomic ion page is -1. So Na is going to get kicked off. Plus, then we get Sn joins up with NO3. Na, is he a diatomic? No, he's not. So he just stays by himself. Sn was +4 because they're Roman numeral 4. NO3 is a -1. All right, so those don't cancel, so we got to put this in parentheses and bring that 4 across. So we get SnNO3, 4. Now we do our balancing. So we got 1 Sn, not 4, because that just means it's charge. Plus we got an Na, an N, and 3 O's. That's equal to an Na plus we've got an Sn, then I got N and 3 O's 4 times. Because that 4 that was on the outside. All right, SNs, I got 1 Sn, 1 Sn. I got an Na, an Na. I got 1 N, 4 N's. Ooh, I gotta make some more of these guys. There's 2 N's. There's 3 N's. There's my 4 N's. I messed up my NAs. Now I got 1, 2, 3, 4 sodiums. So I got 2, 3, 4. I gotta look at my oxygens. I got 1, 2, 3, 3, 6, 9, 12 of them. Over here I got 3, 6, 9, 12 of them. All right, I gotta put in my numbers, 1, 2, 3, 4. I got 4 of that guy and 1 of that, so I just leave it blank. That's my final answer. So, we'll see you guys next time. Have a great day.